In the previous video, we learned how to factor a quadratic expression, that is, a trinomial that has x squared as its largest term, or its largest degree with decreasing degrees of x, where the a value was not equal to 1. And we did that using a method called split the middle term. I'd like to show you another method that can be used to factor a quadratic expression that has these criteria as well. And it's called the Berry method. And again, it doesn't matter to me which method you use. You choose the one that makes the most sense to you. So here's how the Berry method works. We say factor this. And again, your number one step always when you're being told to factor is to ask yourself, is there a greatest common factor that I can take out first? We notice that 3 is our limiting factor. And so, does 3 go into 20? Does 3 go to 28? No, we can't take 3 out because it's not a factor of 20 or 28. So there is no GCF, but we did check that step. We don't have 4 terms, so we're not factoring by grouping. So now we realize that we have a trinomial, and we're going to have to use our thinking chart. So we need 2 numbers that multiply to give A times C, or 3 times 28, which comes out to 84. And those same 2 numbers need to add to give a sum of negative 20. So since they multiply to give a positive value, but they add to give a negative value, we know that they both have to be negative. Now, maybe you can't think of those 2 factors off the top of your head. Remember our strategy of starting with 1 and 84, and then 2, in this case it'd be 41, and so on. We don't need to do 1 and 84. We know adding them is never going to be negative 20, even if they're both negative. Same with negative 2 and negative 41. They're going to be negative 43. We're nowhere near negative 20. So why don't we start by using negative 3 and negative 28. Well, we add those together, they become negative 31. So we're not quite at negative 20 yet. We need 2 numbers that are a little closer to each other. What happens if we try negative 4? Well, the other factor that multiplies then to give 84 is 21. We add those together, we get negative 25. Getting closer. I can't use 5 because it doesn't end in 5 or 0. Can I use 6? Well, 84 divided by negative 6 would be negative 14. And lo and behold, they do in fact add to give negative 20. So let's hang on to that just for a moment. Over here in the Berry method, what we're going to do is an intentional error. We're going to set up our 2 binomials that we know the answer will end up being when we factor a trinomial. And instead of putting x and 3x to get 3x squared, we don't know which one is going to go where. We're going to intentionally write 3x and 3x. So in other words, take this term, reduce its degree by 1, and write it in both places. Now what you recognize is that you've intentionally added an extra factor of 3 that we're going to have to take out of the final answer at the end. So I'm just going to write it off to the side and make a little star to remember that. Okay? So this is kind of a funny way to begin, but let me show you how it resolves itself. Let's now take your negative 6 and your negative 14 and put them into these locations here. In the Berry method, the next step would be to look at both of these terms and ask yourself, do either of them have a GCF that could be pulled out? So when I look at this first one, I recognize that 3 is a GCF that could be pulled out, and that would leave me with x minus 2. This one has no GCF, 3x minus 14. So now this is close to my final answer because nothing is factorable in the brackets anymore, but remember that extra factor of 3 we introduced? Well, we're going to have to take it out. So where is it? It's right here. We take it out, and I'm totally happy if you just leave your final answer looking like that. Okay? If you'd rather have it cleaned up, you could just say the final answer is x minus 2 times 3x minus 14. And if you were to FOIL this out, you should end up with this as an answer, and that's how you'll know you got it right. Let's try another example together. Let's try factoring negative 6x squared plus 7x plus 5. And if you are told to factor this, your first question is, well, is there a GCF that I can pull out? And the answer is no, because both 5 and 7 are prime numbers. We can only take out 5 and 1 in the case of 5, or 7 and 1 in the case of 7. However, you'll notice that we've been factoring quadratic equation or expressions when there is a positive value in front of x squared. So what could I do so that there's a positive value in front of x squared? And this does in fact make my life a whole lot easier. What I could do is take out a GCF of -1 out of each of those terms. That would allow my a value that's left over in the part I need to factor to be positive. And it's going to mean an ultimate change in the signs of the other two if -1 were to be distributed to both of them. All right, so now I need to factor this. I recognize it as a trinomial. It's got a GCF out, means I need to set up my thinking chart. Before I do that, if you like, we can do the intentional Berry error. We can say 6x squared is equal to 6x times 6x, even though we know it's not, but it means that we've introduced an extra factor of 6 that we're going to have to account for at the end. So I'm just going to make a little star off to the side so that I remember to do that. So I need two numbers that multiply to give 6 times -5, and that add to give -7. So I need two numbers that multiply to give a negative number, means one of them's negative, one of them's positive. But the negative one will be in excess because when I add them, I have to have more negatives left over. In fact, I have to have 7 negatives extra left over. So I could start with 1 and -30, but that would give me -29. Let's start with 2 then. 2 and -15. Well, when I add those, I get -13. I'm getting closer. What happens if I try 3 and -10? Lo and behold, I get -7 as their sum. So let's take these two, this +3 and this -10, and let's put them in here. The next step of the Berry method, as we showed up here, is there a GCF embedded in each of these binomials that we need to take out? Well, in this first one, yes, there is. I can see that these both can have a factor of 3 taken out. With 2x plus 1 left over. And if I look at these ones, I can see that those are both even numbers, and the biggest GCF for those two would be a value of 2. And I would be left with 3x minus 5. So these are a lot of things being multiplied by each other, and I'm using brackets to show multiplication just because it keeps the solution clean. It doesn't make it confused with a bunch of x's. But remember that extra factor of 6 that we introduced intentionally in solving for it? Well, now we have to take it out. So where is it? Well, I don't see a 6 anywhere, but I do see a 3 times 2. That's your factor of 6. So when you remove those extra factors that you intentionally introduced, you end up with an answer of -1 times the binomial 2x plus 1 times the binomial 3x minus 5. By the way, this -1 that I pulled out here at the beginning, we're going to talk about its role when we get to quadratics much later in the course. So don't be surprised sometimes if we need to take a negative out so that we can be left with an a value that's positive in order to do our factoring. Let's try one more example to see how the Berry method goes for you. And again, I want to remind you while I'm cleaning up here that it doesn't matter to me if you split the middle term or a Berry method to factor your quadratic expressions. I speak both, and I'm happy if one of them resonates more with you than the other. So again, if you're told to factor this, with this being 48x squared plus 28x minus 6, your first step always when you're told to factor is there a GCF? And we notice upon inspection these are all even numbers, so a value of at least 2 could be taken out. But could we go any further? Well, let's focus in on the smallest one because it's the most restrictive of all the other ones. It doesn't have as many numbers that multiply to give it. 48's got all kinds of them. 2 works. Would 3 work? Well, 3 is not a factor of 28 or 48. It is 48, but not 28. Can't do 4, can't do 5. Could we do 6? Well, again, 28's not a multiple of 6. 48 is. So we're going to have to take out a factor of 2. So let's do that first and see what we're left with. There we are. Okay. I need to factor this. If you want to use the Berry method, you could start right here and say 24x times 24x at the beginning of both your binomials. And then again, make sure you recognize that you've got an extra factor of 24 that you're going to have to take out at the end. Let's use our thinking chart to come up with 2 numbers that multiply to give a times c. So a times c, 24 times negative 3 is negative 72. And they have to add to give the b value, which is 14. So if they multiply to give a negative, that means I've got opposite signs. And because they have to add to give a positive, the larger of the 2 will be a positive. I'm not going to start with 1 and 72 or even 2 and 36. We could see if 3 is divisible into 72, and it is. So we could do negative 3 and 24. But, you know, some quick mental math says that's not going to be equal to 14. Why don't we keep going up the ladder? Let's try negative 4. And you discover that 72, when divided by negative 4, gives 18 as the other factor. Hey, add those together and we've got our 14. So now let's put both of these into here. It doesn't matter which one goes where. Okay. Our next step in the Berry method is to identify if there's a greatest common factor in each of these. So, our first one here, we can take out a GCF of 4. Let's keep it in brackets so the multiplication operations are maintained. And I guess I could leave that orange just so you can see where it all came from. And in this one, 18 and 24 are both multiples of 6. I think that's the biggest factor I can take out. And then I'd be left with 4x plus 3. If you're not sure if 6 was the biggest, you can always look here and ask yourself, is this still factorable? Is there something that could still be taken out of 4x and 3 as a GCF? If there is, you didn't choose the biggest one at the beginning, you can go back and fix it. Okay? But since these don't have a GCF, I'm good to go. Final step in the Berry method is to remove that additional factor of 24 that I intentionally put in. You don't see it written as 24, but I do see it as 4 times 6. So, final answer would be 2 times 6x minus 1 and 4x plus 3. And it doesn't matter what order these are in your final answer. They mean the exact same thing. So there you go. There's Berry method for you. In our final video for this lesson, we'll do a comparative side-by-side between the split the middle term method and the Berry method so you can see the pros and cons of both in making your choice how you want to proceed forward.